According to the basis of that class, we already know that what is the simple pendulum and what is its time period. How we can calculate the time period of simple pendulum. So the formula is P equals to 2 pi under root L upon G effective. Okay, where small l is the length of this thread and radius of the bob, and G effective acceleration due to gravity. So if you want to do more better, so you have to know some additional term about the simple pendulum. Like if this pendulum is vibrating in a lift, moving upward or downward. So if the lift is moving upward or downward with a constant velocity, so there is no acceleration in the lift. So the effective gravity remains same as the acceleration due to gravity at that place. So the time period is same. But if the lift is moving upward or downward with an acceleration small a, then the time period of this is the lift, frame of the lift, and the pendulum is inside the lift, and the lift is moving upward with an acceleration a. So in this situation, the time period must be P equals to 2 pi under root L, or where G effective is acceleration due to gravity added with the acceleration of the lift. This is the condition. So it's very simple. If the pendulum is vibrating in a lift moving upward with an acceleration a, then the time period of simple pendulum becomes this T equals to 2 pi, the length of pendulum divided by the gravity plus the acceleration of the lift. Similarly, if the lift is moving downward, so 2 pi under root L, now the effective acceleration becomes G minus A. So the acceleration of the lift should be subtracted from the acceleration due to gravity. So this one is the second condition. If the lift is this and the pendulum is vibrating in this and the lift is going downward with an acceleration A. So this is for the upward motion. And this is for downward motion. I think it should be clear now. But now we discover new condition. Like the pendulum is vibrating and we place this pendulum on a moving vehicle, like on a truck, and which is also moving forward or backward with an acceleration A. What happened then? Let's discuss. So according to our new condition, like this is a vehicle which is moving forward with an acceleration A, and this pendulum is placed. This pendulum is vibrating in this manner on a moving vehicle A. So the acceleration due to gravity is acting this. The acceleration is in this direction and the acceleration due to gravity is in this direction. So what should be the effective gravity here? So you can see this is the linear acceleration and this is the vertical downward acceleration, and both are perpendicular to each other. So the effective acceleration, if we consider it A, then it should be under root G square plus A square, and this should be the effective acceleration, and call it effective gravity when the simple pendulum is placed on the moving vehicle and the acceleration of vehicle is small. So now the time period is this. T equals to 2 pi under root L upon the effective acceleration is this. So it should be under root G square plus A square.